In this video, I have an epilator. This is something to remove hair, but the problem is it works intermittently. So here's the power cord, and I'll just demonstrate what's happening. So I'll just plug it in, and I've plugged it in there, and I've turned it on, and then I've fiddled with the wire. It's working, not working, working, not working. So we can see there's definitely something wrong with this wire. So I'm going to demonstrate how to fault trace such a problem. All right, so the first thing is to inspect the wire. So I'm starting on the AC adapter side. This is intact. This is called the strain relief. And what I'm going to do is I'm looking to see if there's any tears. Now, one of the things that happens with appliances, especially things that get moved a lot, is look at this cable. It's become totally twisted. So I'm going to inspect this cable step by step. All right, so I'm looking at the strain relief. I'm not seeing any tears there. It's looking okay. A common problem is right here. But this is the AC adapter side. So the major problem would be on the side which is closer to the epilator, which I'm going to get to in a moment. But I'm just inspecting this. I'm untwisting this because notice how twisted this wire has become. So I'm just going to untwist this, and all these twists actually age the wire. So I'm just untwisting it manually like this. Now, you might think, well, maybe if you could just pull it tight and then it would untwist. Unfortunately, I would be putting too much pressure on the wire and I might even tear it. So this is a bit of a tedious job. I need this cable to be completely flat. I need to be able to inspect the whole cable. So that's why I have to untwist this manually. So the cord has now been untangled. Now I want to see if there's any fault along this cord. So what I'm going to do is I'm going to do a visual inspection. So the first step is to inspect the strain relief. Now I can see that the strain relief is in good order. There's no tears. It still has good support. So now I'm taking my fingers and I'm feeling this wire right here where the strain relief ends. There's no bulges. It is still in very good condition. Now I take the wire and I put it between my fingers and I feel if there's any bulges. If there's a tear in this wire, there will be a bulge. So I'm pulling the wire through my fingers and it's of uniform thickness, meaning that it doesn't go thin, fat or something like that, because that's where you would find that the copper inside here has broken and then it gets thin. You'll see that it gets thin, then fat again. So right now it is even. There's no imperfection. There's no change in the thickness of this cord. So I go through the whole wire like this. Okay, I do feel something over here. There is a bit of a bump here. So I'm just going to look a little bit further here and feel it. And what I could do is even plug in the unit. So I'm plugging in the unit. I've switched it on, but it doesn't work. So now I can leave this on and I can actually feel along the wire. And if there's any place where there's an imperfection, I can wiggle it or move it to see if suddenly the epilator comes on. Over here, there is an imperfection. I'm bending it like this. I'm bending it like that. I'm bending it like this, like that. And the epilator still has not powered on. So it means that it's probably not here. I feel it with my nail. It is even. It was just that it had a harsh bend. So I think it's actually fine. All right, there's another one. I can see it is imperfected there. And I just move it around, move it like that, move it like that, like that, like that. Even try and push it together. It's like I'm taking the wire and I'm trying to push it, compress it. Because if the copper broke, it means it got pulled too hard. So I'm actually trying to squish it and still nothing. So it's probably not that. So far, everywhere seems to be okay. Now I've got to the other strain relief. This is the strain relief on the device side. And I'm inspecting the strain relief. Also seems to be okay. But right here, there's an imperfection. I can see there's an imperfection here. It's actually torn. Look at that. All right, so I didn't see this before, but now I can see that there's the break. And when I bend it, there we go. So there's the problem. So what's happened is right here at the strain relief, because look at that, it can just bend inside there. There is the problem. So the wire has been pulled or fatigued. And now what we have to do is we have to join that piece of wire to that one. But unfortunately, it's right here by the strain relief. So even if I just soldered that to that, unfortunately, in a short time, it would just break off. So I'm going to have to sort this out. All right, to buy the new AC adapter plus this specific jack, you probably find it's half the cost of the whole epilator. It's probably not worth it. So I'm just going to fix this. Now, before continuing, make sure you unplug the power before doing any further fault tracing. The first step is to expose this wire. So what I'm going to do is I'm going to open the strain relief a little bit to expose the original wire. So I'm just cutting some of this protective covering away. There it is. So that's what I want to get to. So what I'm going to do is I'm going to have to build a new strain relief here. So I'm just going to open this up a little bit more. Right, so I can actually cut this off here where it's broken. It's fine. I'm just going to cut this off. I'm going to expose the wires on this side. So there is the jack, which I'm still going to need. I'm going to just open the copper like that, and I'm going to open the one side a little bit longer than the other side. You might notice that the one is offset from the other, and you'll see why that's important just now. Now, if this whole wire is still fine, I can reuse it. If it's not, I would have to substitute and get a new wire. So this is where it broke. So I want to open this a little bit, and I want to get to some fresh wire that hasn't been bent and damaged. So So I'm just going to expose the copper here. Now recall, I've offset this a little bit. So the one wire must be a little bit longer than the other, and I've just checked which one because the one's got a line on it, and that's the one that needs to be a little bit longer. So it's going to be like that. All right, so these wires are going to be soldered together. So now the next step is to get these wires ready for soldering. So I'm just going to twist them and then going to cut them a little bit shorter. Now I'm going to take a soldering iron and just tin it. And this is a quick thing because I don't want the insulation to heat up. So it's just tinning it. And over here. All right, so now I want to use a heat shrink. I would have to put the heat shrink over here. I'm not going to use yellow because it doesn't look good when you use the open flame. So I'm going to use black. And if you want to, you can even use a variety of sizes. So I'm going to use a bigger one and a medium size. So there you can see there's actually two. And this will be useful because I can lap the bigger one over the one that's going to go on this side. And I'll show you what I mean by that in a moment. So you've got to put the heat shrink on first. Now I'm going to solder this to that. But I also want to put some heat shrink for these little wires. So this also has to go on first. And now it's time to just solder this. I can see there's a little bit of a burr here, so I'm just going to cut that off. So I'm just making it a little bit thinner. Once it's cool, I can then slide the heat shrink over the wire. So the one side is done. And now it's good to quickly do a test. So at this point, I can plug it back in. All right, and plug it there. And straight away it's on. We can see that, wow, now it's reliable. You could just quickly do some tests along the wire just to see if there's any other faults. So I can now continue with the repair. All right, so the first step is to just heat this up to shrink it. All right, so that has shrunk the heat shrink on around the joints. I'm just going to take some white tape and just give it an extra layer here in between, a layer or two. And I'm just tying these two together nice and tight. Yes, this is repaired, but if it moves like this frequently, it will just snap. So now I need to give it a bit of a spine. So you can take some plastic from maybe a cable tie. Over here is a white cable tie. I've cut some pieces off and I'm going to build a spine. So what I'm going to do is I'm going to put this plastic here, and what it's going to do is it's going to be firm, so it's not going to be able to move that easily. And you could also put one on the back, maybe a bit shorter. And the reason why it's shorter is, of course, it mustn't be so firm that all the pressure's over here. It must allow a little bit of movement. So now I'm going to tie this very tightly with this insulation tape. There, it's giving a bit of relief. We can see that it does bend a little bit. Most of the movement will be here. If someone does press on it, we can see that it does flex a bit, but it is quite stiff. So now what I can do is get those heat shrinks out. So I'm going to slide this one like that, and it's just on the section there. Now I'm going to take a thicker one and put it over here, but I'm not going to use yellow actually because it discolors very easily. I'm going to use maybe blue, but I don't want it so long. So I'm going to cut it a bit shorter. Yeah, that's fine. So it's going to look like that. And then this one is going to go over there. I'm going to first tighten this one. And the way you do the heat shrink is you go from the middle towards the outside. So we get the air out. If I close it here and then go to this side, then I'm locking the air inside. I want to go from the middle and I want to allow the air to come out. So now I can put this one. Now it's important to just check that it will still fit in here. I don't want the heat shrink to get stuck. Yes. So this part doesn't go in there. So the heat shrink can go quite far towards the end. Now this part at the back, it's quite fat. And that's why I have this extra heat shrink here, which is going to go over this part here. I can remove a little bit of this, maybe just like that. And now I can take this one and slide it over. There we go. I wait for it to cool down and then I can just wipe it. Right, so we've built up this. It's quite firm here. It can bend if you really need to. So if you like force it, it's not going to snap. It's got still a bit of strain relief here. So this part with the fresh wire, it can move, but it's got a little bit of rigidity. So what it does is it allows for movement over a longer length instead of just like that, because that's where it will break next. But because it can move over a longer length, that's what will save this wire. Okay, so there is the new connection. So just to do final checks, plugging it in, turning it on. Now while I have it here, I'm going to quickly do a final check, just checking that everywhere along this cable is fine, because there was a place where it was a little bit swollen, and I'm going to just quickly check it. It was over here and I'm just checking, nah, it's perfect. And along the whole travel, this cable is fine. So if this cable was faulty, maybe in the middle, or it had a few breaks, then I would need to replace the whole cable. So what I would need to do is find a replacement cable. Here is a replacement one, but please note, if you are replacing the whole cable, it cannot be a wire like this. This is called a solid core wire, and after several bends, this is what happens. It breaks. That's why it has to be stranded. Stranded is more resilient when it comes to continuous movement. All right, thanks for watching, and cheers.